And here we are. Here's the main thing. Let's add a sound. Let's call it bang. And here are all of the plugins we can add. Each of these is a different plugin. The sounds are applied one after another. Let's start with a simple grey wave. Now that, if I press a key, Q key, or click play here, you hear what it's doing. So control the level. And this button here will attach a modulator to the sound. So we've got, this would match the level, depth 1. If I set this to level 0, that will fade from 1 over a course of 1 second. If I turn down that, it changes the depth. Now these modulators are just wave files, so I could replace it with, let's try fade linear. Hear the difference. I could replace it with a loop. I could change the speed, turn length is faster. I can combine them, so if I fade, combine that with a fade, I get that sound. Turn off the loop, make it longer. Because these are just wave files, there's a massive amount of processing you can do to these. I can center it, I can change the depth of value, I can switch the phase around, I can invert it, reverse, but for this example I'll just replace it with a simple fade like this. And again, it's applied to the level parameter, but it can apply to any of the parameters of any of these plugins. That's what makes it so powerful and incredibly quick. So there we are, depth 8 makes a bang sort of sound. Now, I think I will look through some of these. Let's try a flange effect. Doesn't really do much at the moment, because flange depends on a modulator attached to something. So let's try a triangle wave. There you go. Again, it's length 0. Well, that works quite well. If I change the depth, you can see that the delay starts at 2. So this will go up to 1, that is 3. Down -1, that's 1. So it varies between 3 and 1. If I turn down depth, you can hear the effect isn't as strong. If I turn it up, it's a lot stronger. Now, what can we add? We'll add band distortion. This is sort of like a bandpass filter with a bit of boost to it. There's the cutoff frequency. The frequencies are all in non-standard values from 0 to 1. That's simply because it will make it easier to attach a modulator like this. There is a direct conversion. A cutoff of 1.0 is 22,000 hertz. There's a table and a formula to convert the values. But in practice, it's about doing it by ear anyway, a lot of sound design. So let's attach the loop to the cutoff frequency, set a depth of about 0.1. You can hear what it's doing, you can see what it's doing. That's the brilliant thing about it. If I turn loop off, you can see it just plays it through once and then stops. Let's turn it down here. Now let's turn up the dry and you'll be able to hear the white noise as well overlaid on the boost. If I turn off wet completely, you get no band distortion effect at all. And again, all of these values can be changed. You can attach a modulator to anything. That's what makes it so powerful. Let's give power a boost. That's quite an interesting bang. Right, now let's add a pulse wave. Why not? You can see all the effects are applied one in order. This one, then this one, then this one, then this one. And it will keep playing until hit stop, which is the same as the space bar on the keyboard. Every time you hear a sound, by the way, like this, it's me pressing the Q key on the keys, but you can click play there as well. Now let's fade this out, fade linear. You can, because that's a level of 2 and this fades to 0 here, it will be 2 at the end. If I turn this to 0, or -0, it doesn't matter, they're the same. -0 is a valid number in floating point numbers, but you can type any number here anyway. And in fact, the number you type here is 6-digit precision, so that's you've got loads of control. Right, let's make it really quick. You can hear that. Let's change the phase to change the sound this way. Let's change the pitch, why not? Let's have it. Let's have another sine loop, shall we? Change it to 12, a full octave. Brilliant sound. How about that? Amplitude modulator is a basic volume control, so we can use it to turn down the whole result. And now we've made a sound called bang.